Video we're going to be exploring how to solve radical equations, and I don't mean like really super awesome equations. I mean equations that may sometimes include some sort of radical in the expression on one side or another. Maybe we have two radicals, okay? So we're going to be dealing with expressions that involve these today, but solving for a variable that happens to be on the inside of a radical. So the key step here, the key skill or property we're going to be using is this powers property of equality right here, but it says the key will be to raise each side of the equation to the same power. That is, if two things are equal, if A equals B in an equation, left side equals the right side, then basically what this says is we're allowed to raise both sides to the same power because they would have to be equal. Essentially if I said, x equals 2, well then, 2 squared equals x squared, and that would be like saying 4 equals x squared if x equals 2. So that being said, we're going to use this powers property of equality to solve these things. So I say after eliminating any radical expressions, we'll solve the remaining equation using standard procedures. So essentially what our goal here is to be able to do is to eliminate the radical and then just go deal with this like a typical algebraic expression. So really quickly, I'm just going to run through some quick examples, and then we're going to extend these examples in the next video. So starting with this one here, we say solving a simple radical equation. It says, please and thank you, solve for the number that when we take the cube root of it and subtract 4 from it, we get 0. So now, the thing is, I can already think of a number in my head, but solving this algebraically, what we want to do is this. We want to, 1, isolate the root, okay? So we say the root. And by the root, what I mean here is this, excuse me, cube root of x. So I notice that this cube root of x has a 4 being subtracted from it, which means that 4 is going to have to go. And I also notice that it has a coefficient of 1. And that's one thing I do want to point out. We're not going to have to deal with this coefficient of 1, but if it were a 2 or anything else, like not 1, we would have to deal with that also. So isolation of this cube root means that we are going to add 4 to both sides, okay? So we've just completed the first step in any equation, of course, when you're solving a radical equation like this, is isolate this. So what we're going to do now is, again, remember we were going to use this powers property of equality. And what I know is this. If I wanted to get rid of a cube root, the inverse of the cube root would be the cube power, okay? So I get this right here, and what do we know about the cube root of, x, that thing cubed? Well, that's the same thing as the cube root of x, cubed, but that's just x. So what we're really doing is we're ending up with x here, and we say x is 4 cubed, really, 4 times 4 times 4, so we get x is 64. And one thing I do want to mention here is this: you're solving an equation. So what we need to do is check this answer. So to outline my steps again, the first thing we did was isolate the root. The next thing we did, I suppose we could write as a step, is we raised both sides to the appropriate power. Such that we get the thing isolated here. And then the third thing I want to do is solve for the unknown, and then the last thing you should always do is this: you should check your answer. So check answer. We're going to find some today that the answer actually, it works out algebraically, but it doesn't work when you plug it back in. So for instance, what I mean here is this. This equation was the cube root. We'll try this a little smaller here. The cube root of x minus 4 is equal to 0. If we were to now go back and directly substitute this value of 64 that we think we get for x here, that's what our x value is, then we get the cube root of 64, is 4, and we get 4 minus 4 is 0. So 0 equals 0, and this is a valid statement, okay? So let's go ahead and take a look at letter B here. Letter B is a little bit different. That is, we have to isolate first this fourth root of x, okay? So the deal here is this. We both have a positive 5 out front, but also a negative 1 times this. So just like we always solve algebraic equations by undoing addition and subtraction first, the first thing I want to do is subtract 5 from both sides. What that's going to do is get it off of this side. And I want to point this out here. That negative is in front of this radical right here. So what we need to do now is we actually need to divide by both sides into negative 1. Okay, so those cancel out. We get left with the fourth root of x, and the fourth root of x is equal to just a positive 5. So now that we have this isolated, okay, we're going to raise both sides to the appropriate power. And I say, well, the appropriate power to take care of a fourth root would be the fourth power. So I would get really this. I would get x equals 5 to the fourth, which is really 25 times 25 is 625. And the last but not least, what I want to do is this. I'm going to check my answer. So I say 5 minus the fourth root of blank equals 0. I'm just getting this from my equation, the original equation up here. And we're plugging in this x value of 625. So 625, I mean, you could figure this out here. I mean, a calculator could do that. If we wanted to find the fourth root of 625, I suppose we could say 625 to the power of, and then we say in parentheses 1 divided by 4, because that would be the same thing there. And we get 5. So we get 5 minus 5 equals 0. So 0 equals 0. So that must be the solution. So that's how you would take care of a radical equation. You isolate the root, take care of it with the power, and then solve it and check your answer. Cheers.